Hello, we're going to go through the Chapter 5 test review together. Please fast forward to the questions that you need to look at. So for number 1, it says put it in standard form, then classify it by its degree and the number of terms. So standard form is just rearranging the terms from exponents being highest to lowest. Any like terms, we want to combine them together. So for this first one, we have 6x to the fifth minus 2x to the fifth. They're like terms, so we take 6 minus 2, we get 4x to the fifth, and then it's minus 2x squared plus 1. So we combined our like terms, so we put our exponents highest to lowest. Now we can answer the questions. The degree is what is the largest exponent, so that is 5. And the number of terms is how many groupings are there? There's 1, 2, 3 groupings. Let's go to number 2 now. So the leading term would be 6x to the third power, and then plus x to the second power. Negative 3x minus 5x would give us negative 8x plus 1. This one, the largest exponent would be 3. And the terms, there's 1, 2, 3, 4 terms. Please make sure you put them in standard form first before you classify it by its degree and the number of terms, or you'll get that part incorrect. Number 3, it says what is the end behavior. So for this one, we could go ahead and graph it and look to see what the ends are doing, or you can just put it in standard form and look at the leading term. So if we put this into standard form, we have 2x to the second plus 3x minus 4. Notice the leading term is the even power. So for this one, since the degree is 2, it's going to be a parabola. It is a positive 2, so both arrows are pointing up. So we would say the end behavior, this one's pointing up, and then this one's pointing up. And if you're not sure, looking at it in standard form, just go ahead and put it into your graphing calculator to get that graph and then just tell what the ends are doing. For this one, it is already in standard form. Looking at the leading term, the arrows are going to be going in opposite direction because it is odd. It is positive, so it's going to be increasing. So it'll look something similar to this if we went ahead and graphed it. So it's down and then going up. You want to look at it from left to right. Okay, and they don't care about all the curves in the middle, they just want to know end behavior, what are the ends doing. For number 5 and 6, they want to know, find the zeros, state their multiplicities. So for these ones, we're just going to set them equal to 0. We're going to solve for them. So we get x equals negative 2, x equals positive 3, and then their multiplicities are how often do they occur, and so we're looking at the exponents. If it doesn't have an exponent, it's going to have an exponent of 1. They will never have a multiplicity of 0. That means it does not exist, and both of these solutions exist in this problem. So this first one has a multiplicity of 1, and then x equals 3 has a multiplicity of 2. For this next one, we're going to have to factor it first. So x squared goes into both of those terms. Then we have x plus 4 left over. And then we can set them equal to 0. So it's x equals 0. The multiplicity is 2. And then we get x equals negative 4. And the multiplicity is 1. For this next one, it says find the real solutions of each equation using a graphing calculator. Round to the hundredths place when necessary. So for this one, there's a couple different options that you can do. You can try to either factor it, graph it, use the quadratic formula. If you look at those options, the quadratic formula we cannot use right from the start, because the highest exponent is 3, so we can only use it when the highest exponent is 2. We could try factoring it, but it doesn't have a greatest common factor. If you look at the terms, it doesn't look like it's going to factor very easily, so I would go ahead and graph it to start with. So if we go to the y equals on our graphing calculator, I apologize, I did not bring a graphing calculator home, so you're just going to have to go to y equals, type this equation in, and we're looking to see where it crosses the x-axis. And so for this one, it crosses the x-axis at 0.75 or 3/4. It doesn't cross again, there's no turning points there, so this is our solution. That means the other two are imaginary. It just wants the real solutions, so we do not need to find the imaginary ones. If we go to this next one, we're going to have to subtract 4 from both sides, get it set equal to 0. And then now we can go ahead and graph it. So we're going to go to the y equals, type it in, click graph. This one, it crosses the x-axis at 2 places, so we'd go to second trace 0, which is down to number 2, and then do the left bound, right bound, and it crosses at positive 0.886 and negative 0.86. There's no turning point at either one, and it only crosses at 2 places, so that means the other two are imaginary, but we do not need to find them. The next 4 problems that we're going to be using long division or synthetic division, we're going to take a look at all 4 of them using synthetic division. So whatever we're dividing by, we're going to set that equal to 0. Solve for it, so we get x equals negative 4. So negative 4 is going to be the number in our box. And then look to see if they skip any terms. It goes 2, 1, and 0. So we can just write those numbers down. It doesn't skip a term. We drop that first number. It doesn't matter what it is. We just drop it. And then we multiply our diagonals, add our columns. Multiply our diagonals, add our columns. And then that last number is always going to be our remainder. Whatever our exponent is here, it's going to be 1 less than that, so 1x to the first power plus 2x, and then just count down with your exponents. So that would be x to the 0 power, which we don't need, and then the remainder is 16. If we go to this next one, we set this equal to 0, solve for it, and we get x equals negative 1. So the negative 1 is going to go in the box. It goes 3, 2, 1, 0 for our exponents, so we could put our coefficients or numbers out in front. We drop that first number, multiply our diagonals, add our columns, multiply our diagonals, add our columns, multiply our diagonals, add our columns, and then we're going to put in our variables. It started with to the third power, so it's going to be 1x to the second power plus 1x plus 3 remainder of 7. Go to our next one. We're going to put negative 2 in the box. Goes 3, 2, 1, and 0. It doesn't skip a term, so we can write our numbers down. Okay, so then we put in our exponents. Alrighty, the last problem, we put a positive 1 in our box. It goes 3, it skips 2, so we're going to need a 0 there, and then x to the first power, and then our number. So 2, 0, negative 4, 3. Put in our variables. Alrighty, this next problem, it says write a polynomial function with the rational coefficients. So for this one, we know there's these 3 solutions. There's no i's or square roots with them, so we don't need the plus or minus sign for either of them. So then we're going to go straight to our factored form. We're going to plug in the opposites for each of them. And we need to plug in the opposites because when we set these equal to 0 and solve for them, then we'd get each of these solutions. And we can just leave it in factored form. We will not need to put them in standard form. For this one, notice there's an I here, so we're going to need that plus and minus sign in front of it. There's a square root here, so we're going to need that plus or minus sign in front of it. So there's actually going to be 4 sets of parentheses for this problem. We're going to need y equals x plus ri, x minus ri, x plus square root of 2, and x minus square root of 2. So anytime that there's an I or square root, you do need to remember that plus or minus sign, that you're going to need both of them. Now 15 through 17, that is just extra practice on problems number 5 through 6. Alrighty, we're going to take a look at number 18. It says use the rational root theorem to list all the possible solutions and then all the actual solutions. So for this one, to find the possible ones, we're going to take the last term divided by the first term. So I'm going to, since it's last divided by first, I'm going to put the last term on top, so 6, put the first term on bottom. We're going to write all the numbers that divide evenly into 6, so 1, 2, 3, and 6. All the numbers that divide evenly into 1 are just 1. And then we're going to take all these last terms and divide by 1. So the list of possible ones are going to be 1 divided by 1 is 1, 2 divided by 1 is 2, 3 divided by 1 is 3, 6 divided by 1 is 6. And we need a plus or minus sign in front of each of these. If you do not want to put a plus or minus sign in front of each of them, you can just put it out in front, and we'll know that it goes with all of them. So that is our list of possible ones. It is not going to cross through all 8 of those places, but that is where it could cross. Now for the next one, we want to find our list of actual ones. So to find our list of actual ones, we're going to go ahead and graph them and see where it crosses the x-axis. So if we go ahead and graph this, you'll notice it crosses at -2. Even though our degree is 3, we just want the rational roots, so we're not going to have to go find the other 2 solutions. This next one, we go ahead and take our last term divided by our first term. All the numbers that divide evenly into 12. All the numbers that divide evenly into 1. So for our list of possible ones, we're going to take all of these last terms divided by the first term. So 1 divided by 1, we get 1. 2 divided by 1 is 2. 3 divided by 1, 4 divided by 1, 6 divided by 1, and 12 divided by 1. So that is our list of possible ones. And then our actual ones, we go ahead and graph it and see where it crosses the x-axis, and it's going to cross at -2 and +2. And again, we do not need to find the other 2 solutions, they just want the rational ones. For number 20, it says find all the zeros of each function. So whenever it wants us to find the solutions, I would go ahead and graph it. Find the real ones first. You might look out that they're all real, and then you would be done and can move on to the next problem. So for number 20, we're going to go ahead and graph it. Notice how the degree is 3, so we need to find all of them. So they want the real and imaginary ones. So we're going to put x equals off to the side. We know there's 3 solutions, so we're going to put 3 of them. And when we go ahead and graph it, we get that it crosses at -2. And make sure, since I didn't bring my graphing calculator, if you're struggling with the graphing, do ask. But we just go to the y equals, type this in, click graph, and then go to second, trace 0, and do the left bound, right bound, and see where it crosses the x-axis. So this one, it only crosses at -2. So we're going to put -2 in the box and do our synthetic division. Goes 3, 2, 1, 0. So we're going to go ahead and divide by the negative 2. Make sure each time we do this synthetic division using these solutions, we should be getting 0 as a remainder because they factor in there evenly, their solutions. If we're not getting 0 as a remainder, we know we need to go back and check our work. And we have no other numbers to divide by. There was no turning points there. So the other two are imaginary. So we're going to put in our variables. So we have 1x squared plus 0x, which we don't need, plus 4 equals our 0. And then from here, we can either use the quadratic formula. Our a would be 1, our b would be 0, and our c would be 4. Or what I like to do when the middle term is 0, I'm just going to set it equal to 0 and solve for it. So we're going to subtract 4 from both sides. To undo to the second power, we square root. So we have x equals plus or minus, and whenever we have a negative underneath the radical, we need our I, and then the square root of 4 is 2. So plus or minus 2i. And that's going to give us our last two solutions. Okay, make sure you can only have an even number of imaginary solutions. So if we had 3 imaginary solutions left, that wouldn't be possible. But check to see if there's any turning points to any of your solutions listed. Alrighty, let's go to number 21. For this one, the degree is 4, so we're going to have 4 solutions. When we go ahead and graph it, we get negative 3 and positive 3. So we're going to go ahead and use our synthetic division. And it doesn't matter the order in which you plug them in. So this one goes 4, it skips 3, 2 skips 1, and then so we need 1, 0, negative 14, 0, and then 45. Then we're going to use this new row of numbers and plug in then positive 3. So then we're down to 3 numbers. You're always going to get it down to 3 numbers. And we can use the quadratic formula, or this one, the middle term is 0 again. So I would just go ahead and set it equal to 0 and solve for it. So x equals plus or minus square root of 5. If you look at the graph, they're going to give you the square root of 5, whatever that is, as a decimal, and give you all 4 of your solutions right from the start, which you can put it in radical form or decimal form. Alrighty, number 26, it says expand each polynomial. So for these ones, we're going to use Pascal's triangle. So if we go to Pascal's triangle, we want to go to the 6th row. So our 6th row of numbers, if we're looking at Pascal's triangle, is 1, 6, 15, 20, 15, 6, and 1. We're going to want to spread those out. So I'll put them down here. 1, 6, 15, 20, 15, 6, and 1. Notice our two terms are x and a positive 2, so we're going to put an x in parentheses and a 2 in parentheses after each number. And then we're going to put a plus sign in between each one. And then we need to put our exponents. So for the x, since it was to the 6th power, I'm going to go and start with 6 and count down to 0. And then with the 2, start with 0 and count up to 6. Okay, and then we need to go ahead and simplify this. So we have 1 times x to the 6 times anything to the 0 power is just 1. So then when we multiply these, we just get x to the 6th power. We go to the next one, we have 6 times x to the 5th times 2. So 6 times 2, we get 12. and then we're just going to put the variables on the end. Then we go to the next term. We have 15 x to the fourth. 2 squared is 4. So 15 times 4 is 60 x to the fourth. Then we go to the next one. We have 20 x to the third. And then times our 8. Then we go ahead and take 20 times 8. We get 160 x to the third. Then we go to the next one. We have 15 x squared, 2 to the fourth power. We get 16. 15 times 16, let me look real quick, is 240 x squared. And we have 6 times x to the first times 2 to the fifth power is 32. 6 times our 32, we get 192. And then our last one, we have 1 times x to the 0 power is 1. 2 to the 6th power, we get 64. So 1 times 1 times 64 is 64. And then that would be our final answer. Alrighty. Let's do one more of these. For this 27, we have 2x plus 3 to the second power. So we're going to go to Pascal's triangle. We're going to go to the second row. Our second row of numbers is 1, 2, 1. So we're going to spread those out. And then we're going to put a 2x and a positive 3 after each one. We're going to put a plus sign. We're always going to put a plus sign. If, let's say it was like number 28, a 4 and a negative 3x, we would put a 4 in one set of parentheses and a negative 3x in the other set of parentheses. But you still put then the plus signs. So then it was the second power, so we're going to start with 2, go down to 0, and then start with 0 and count up to 2. And then we need to go ahead and simplify each term. So we have 1. This one, the 2x is all to the second power, so you're going to square both of them. So 2 squared is 4, x squared is x squared, 3 to the 0 power is 1. So when we multiply those, we get 4x squared. We have 2, 2 to the first power is 2, x to the first power is x, 3 to the first power is 3. So 2 times 2, we get 4, times 3 is 12. We're going to then put the variables at the end. Then we have 1, anything to the 0 power is 1, 3 squared is 9, so we end up with 9, and then we get our answer. For this one, it might be just quicker to go ahead and FOIL or distribute instead of using Pascal's triangle, so that is a personal preference. Alrighty, for the bottom 4 problems, we're going to be using our transformations. And so if we think about this equation, our A is going to be in charge of stretching or compressing, our H moving it left and right, and our K up and down. So we want to go ahead and vertically stretch it by a factor of 3, so we're going to put that in the A spot. We're going to reflect it across to the x-axis, so we're going to negate it. And then it's going to move to the right 4 units. So to go to the right, we're going to subtract. It's going to be the opposite of what you would think. If we're going to subtract, we're moving to the right. If you add, you'll move to the left. And then we're not moving up or down at all, so we don't need anything in the K spot. So that would be our final answer. If you're second guessing yourself, I would go ahead and graph it and so you can see how it is moving. For this next one, it's a reflection across the x-axis, so we're going to put a negative in the A spot. It's moved to the left 2 units, so we're going to add 2. And then it is moving down 6 units, so we subtract 6. And then it doesn't say anything about stretching or compressing, so we don't need a number in the A slot. Next one, it's vertically stretched by a factor of 5. it's moved across the x-axis, so we're going to negate it, and then it's moved to the left 2 units, so we're going to add 2. Next one, it's reflected across the x-axis, so we negate it, moves to the right 3 units, so we're going to subtract 3, and then it's moved down 7, so subtracting 7. Alrighty. Number 34, there's 2 options that you have for this one. It's saying x equals 2. So we could go ahead and just plug in 2 for all of our x's, use our graphing calculator and just simplify this down and get a number, or you can use our synthetic division. So if we do our synthetic division, we're going to put 2 in the box. We don't put in the opposite just because it's already solved for x equals 2, so we plug that number in. It goes 4, 3, 2, it skips 1, so we're going to need a 0 there as a placeholder. And then if you're doing synthetic division, it's going to be whatever the remainder is. I like to use synthetic division when I don't have a graphing calculator. If you do have a graphing calculator or calculator right in front of you, then you can again just plug in the x's and then click enter and you'll get 38 also. Alrighty, this next one we're going to put -5 in the box. It goes 3, 2, 1, 0. It doesn't skip a term, so we put our coefficients. We get 18. Alrighty, for number 36 it says, can a function with complex roots of 5 square root of 2 and 3i be to the 4th degree? So looking at this one, the 5 doesn't have an I or square root, so that's just one solution. The square root of 2 has a square root, so we need that plus or minus sign. And then 3i has an I with it, so we need that plus or minus sign. So knowing that 5 square root of 2 and 3i are solutions, then we know that all of these have to be a solution. So that is a total of 5 solutions. So the least it could be is to the 5th degree. It might be more if this one has a multiplicity, but it at least has to be the 5th degree. So we would say no. There's at least 5 solutions. Alrighty, number 37 says find a polynomial function whose graph passes through each set of points. So for this one, notice how there's 3 points, so the degree is going to be 1 less than that. So this would be our standard form. This one, there's 4 points, so the degree is going to be 1 less than that. So this would be our standard form. So then we're going to go ahead and plug in these coordinates. So if we plug in the first one, then we're going to make our matrix. Our first row numbers, 0 squared would be 0, 0, 1, and then -3. The answer column always has to be last. Then we go and plug in the next one. So we get -7, so we get -2 squared is 4, -2, 1, and -7. Then our last row, 4, 2, 1, and 9. And then from here, you're going to use your graphing calculator. For this one, we're going to go to second matrix. We're going to go over to the 3rd column. And we're going to then type in this matrix. We're going to click the dimensions are 3 by 4. Then type in all these numbers. And then we're going to go to graph clear. And then we're going to go to second matrix one more time. Then we're going to go to the middle column. We're going to go to where it says RREF. Click enter. and then we're going to go to second matrix one more time. Then we're going to be in that first column, and I always type it in matrix A, so I would have matrix A highlighted, and then click enter. You'll have to click enter twice, and then you're going to end up with a matrix with ones diagonal, zeros elsewhere, and then this last column is what your A, your B, and your C is going to be. This one, it gives us 1, 4, and -3. So the ones diagonal, zeros everywhere else, just means there is a solution. And then again, this is our A, our B, and our C. So we're going to plug those back into the original equation. So our final answer would be y equals 1x squared plus 4x minus 3. If we would go ahead and graph this, all three of those points would be on that graph. If we go to the next one, we're going to type in each of these, or plug in each of these coordinates. So we get 9, alrighty, one last number to plug in. So for this one, we get the answer column always needs to be last. Then we're going to go to second matrix, go to the third column. This one's a 4 by 5. Type in all the numbers, go to graph clear, then go to second matrix, go to the middle column, and go down to RREF. Click enter, and then go to second matrix. If you typed then this in matrix A, have matrix A highlighted in that first column. You used a different matrix, have that one highlighted, and click enter, enter. And then for this one, we get the ones diagonal, and then that last column, we end up with 1, -2, 6, and 9. So then our equation would be y equals 1x to the third power minus 2x squared plus our 6x plus 9. Alrighty, for this next one, it says find all the real zeros of each function. Notice for this one, there's just one x, so we could go ahead and solve for it. Wherever the solutions are, wherever they cross the x-axis, that means what all those have in common is the y value is 0. So we could go ahead and just plug in 0 for a y, and then algebraically get the x by itself, so move everything over to the other side. So if we do that, we minus the 24. Divide by -3. We're going to take the cube root of both sides. So those cancel out, so we get x minus 2 equals the cube root of 2 is just 2. We go ahead and solve for this. We get x equals 4. Another option that you have on this one is just go ahead and graph this and see where it crosses the x-axis, and it's going to cross at 4. So this next one, if we do it by hand, we plug in 0 for our y. And then again, we want to get the x by itself, so we start moving everything to the other side. You can use -5/8, or you can put that as a decimal. cube root of both sides. Those cancel out, so we get negative x minus 2 equals the cube root of negative 5/8. So then we go ahead and add 2 to both sides. So we have negative x equals the cube root of negative 5/8 plus 2. Then we go ahead and divide both sides by negative 1. So we have x equals negative cube root of negative 5/8 minus 2. Or another option that you have for this one is you could go ahead and graph it and see where it crosses the x-axis at. Alrighty, for the next one it says find a quartic function with the given x values. So for this, quartic means 4 solutions. It does say that these are the only real solutions, so that means the other 2 have to be imaginary. You can use any 2 imaginary solutions, just make sure that they're opposites of one another. So I'm going to use x equals I and x equals negative I as my other 2 solutions. So then I'm just going to plug in the opposites, x minus 3, x plus 1, x minus I, and x plus I. So then it's a quartic function because there's 4 total solutions. These are the only 2 real ones, and then the other 2 are imaginary. For number 42, again, I'm going to plug in the opposites. And then the other 2 are going to have to be imaginary. You can use any 2, just make sure that they're opposites. So I'm going to use positive I and negative I again. Make sure we're plugging in the opposites here, because when we set these equal to 0 in solve form, we get back to these 2 solutions. Alrighty, that is it for the review. Hopefully that helps. Please do let me know if you have further questions.